Okay, geometric descriptions. Geometric descriptions. So I have a span of some vectors in three-dimensional space. Now, what do spans look like? Now, let's see. If you have a single vector, you have a span of a single vector, what does that look like? Well, you have your vector, and you have the origin here. And when you take the span, what you get is this line to infinity in both directions. So that would be the span of a single independent vector. Now if you get two, let's say you get two independent vectors, what would that look like? Now imagine this situation floating in space, and imagine I have another independent vector like so. So if I have two independent vectors, I think of it as, how do I think about it? Well, it depends on the day of the week. Today, I will say, well, the span of these two vectors, I certainly get this line here, and I get this line here. But if you think about it, I get everything that's kind of in between those lines, you know. In fact, what I get, and this is the way I think about it, I think about this triangle here. You imagine this triangle. Now I got to visualize this floating in space, that triangle. There is only one plane. There's only one plane. Imagine my hand is a flat plane. There is only one plane that contains that triangle. And when I take the span of these two vectors, I get exactly that plane. Okay, let's recap. Span of a single vector, I would get just a line. If I were taking the span of just this guy, just a line. Span of two independent vectors, you get a plane. The plane that contains this triangle. So that's kind of a two-dimensional object. Now if I were to have a third independent vector, well, that would be three-dimensional. I would get all three-dimensional space. Okay, so what's happening here? I need to determine how many independent vectors I have. Okay, it's going to be 1, 2, or 3. So to do that, I use my old trick of reducing a matrix and counting pivots. Okay, let's see if I can do this without making a mistake or too many mistakes. Okay, I'm going to do row 2, subtract 2 row 1. And then I'm going to do row 3, subtract 3 row 1. And then I'll do row 3, subtract 2 row 2. And that's good enough. I can see that I have 2 pivots. So, therefore, 2 independent vectors in the span. Okay, so I have this triangle thing, okay? I have a plane that contains some triangle. So plane again, plane, number 2, okay, two-dimensional. So I want to say, I can't just say plane, I would say span is the plane. Which plane? Here. The plane, I would say, I want to specify exactly which plane I'm talking about. Is the plane through the origin that is parallel to I can choose any of these three vectors, any two of these three vectors. So if I call these, say, u, v, w, I could say that we're talking about the plane that goes through the origin and is parallel to u and v. Okay, so I went with u and v here. I could have gone with u and w. Okay, you just have to make sure that the two things you choose here are actually independent. Okay, two vectors. To be independent, I just need to check that they are not parallel. Okay, I can't have one of them being a multiple of the other. In this case, thankfully, that's no problem here. Okay, I can just see, just by inspection, I can see that it doesn't matter which two I pick here. I'm going to end up with two independent vectors, and any such combination will work right here.